pyramid with a square base of length 10 if EO is an imaginary line representing the height of the pyramid and EO is equal to 12. So let's first of all make a pyramid here. So here we have a pyramid. Now in this case it's already given that the height is equal to 12. But what height we are talking about? Let me just quickly make a few constructions first, because the height has to meet at exactly the center of the base. So first of all, I'm drawing the two diagonals of base. These are two different diagonals. Now height I will be representing using a different color. So height will be a line which is red line. So this red line has a length that is equal to 12 units. And we already know that the base has each side equal to 10 units long, which means we can understand that the diagonal will be equal to, let's call it A, B, C and D. So we can say diagonal AC will be 10 square root of 2, 45, 45, 90, or you can use Pythagoras theorem. And now we can say that each part of them will be 5. That means this pink line is dividing the diagonal into two equal parts. So you see we have a right triangle here. The right angle that you can see here is this angle. This angle is right angle between this pink line, this blue line. And now we need to find out the length of this, let's call it OC. Right, because OC is basically the slant line that's making the face of this pyramid. And also please understand this fact that what we need to find is basically this shaded region. Right, we need to find out the area of this face and then we need to multiply it by 4 to get our answer. So first of all we need to find out this side. Now let me also make this particular point as P. So I'm taking this triangle OPC. In triangle OPC what I can see is the height is given 12, the base which is PC is equal to 5. That means I can find out the hypotenuse, which will be the length of OC, and that will be equal to the square root of 12 square plus 5 root 2 square. I made a small error. This is not 5 each, these are 5 root 2 each, because the diagonal is 10 root 2 and half of them will be 5 root 2 each. So the length of OC that way we calculate is equal to the square root of 144 plus 50, which is equal to the square root of 194. Now the next calculation that we need to make is to find out the area of this triangle ODC. So for that what I'm going to do is I'm going to make a triangle ODC here. So let me just draw a triangle and take a line. So let's call this triangle O, D and C. O, D and C. This is D, this is C and this is O. So this blue shaded face is the face that I'm taking. Now all these slanted lines are equal to square root of 194. We have already calculated, so it's an isosceles triangle with two sides square root of 194 and the base DC is given equal to 10. Once again, to find out the area of this triangle, we need to calculate the height of this triangle. So we drop a perpendicular that divides the base into two equal halves. That means these sides are 5 each. Now we need to calculate the height. The height will be equal to square root of root 194 square minus 5 square using the Pythagoras theorem once again. So we got 194 minus 25, which is equal to square root of 169, right? Root 169 is 13, so we know that this height is 13 units. That means the area of triangle ODC. Area of triangle ODC will be equal to half of base, which is 10 times height 30, so that becomes 65. So the total area of the four sides, so 4 sides will be 65 multiplied by 4, that is equal to 260, and therefore the answer of the question will be option B. I hope you enjoyed the explanation. Thank you so much.